Welcome. We are ready.
I think we can start. Okay, welcome to this session of let me call it the new Ccamp. As you see, there are a lot of new faces, a lot of differences with respect to the last meeting. We have two new chairs, both of them totally unexperienced, so please be patient with them. We have a new secretary, we have Oscar, helping us with the management of the working group, and we have a new ID, which last time I was sitting here, but this time is sitting at the opposite side of the table. So let's start, as we have a pretty full agenda. Not well, nothing changed since last time. As usual, please say your name when you go to the mic. We are being recorded. Minute takers, we will be using Etherpad, so collaboration minutes. Oscar, we will try to lead this activity. We will be also on Jabber through Mythico. You feel free to be also there, ask questions, whatever you want. Session. We will be meeting for a single session today. We will have 1 hour and 30 minutes. It's significantly shorter than the usual Ccamp timing, but with the new rearrangement, we hope it's going to be fine. As I told you, you have 2 new chairs, 1 new secretary, 1 new AD. IPR process. It's been in place for a while now, so you all should be familiar with the IPR process. We are right now in the middle of an IPR polling for a draft, preparing it for the working group last call. Mailing list. We encourage using the mailing list as much as possible as usual. This is not the typical way of working during this week, but please involve the working group in all the discussions. Document status. We have no new errata. We have 2 new RFCs. Finally, the WSON drafts are making their way through the process. The routing and wavelength assignment information info model is now RFC 7448, and we have also a new RFC on MPLS TP, RFC 7485. We have 3 new drafts which completed the ISG processing, and 2 drafts which are in the ISG processing. We are preparing the FlexiGrid framework for last call. As I told you, there's an IPR polling ongoing. Please, a lot of replies are still missing. Please reply to the IPR polling. not to delay the last call of the draft. Drafts on the working group drafts on the agenda. We will have all of these drafts being discussed, mostly the FlexGrid framework and encoding drafts, and a draft related to the impairment-aware WSON. Working group drafts not in the agenda. We have, I don't know, I see Amy is here. Would you like to say a few words about the drafts to the mic?
Thank you, Chairman. This is Amy from Huawei. I would like to report about the two working group drafts on the availability. One is for the routing extension and another one is for the sync-loading extensions. These two drafts were adopted in last August, and from them there are some editorial changes. And some open issues that we will receive some comments about whether it's possible to generalize to other technologies such as OTN or optical. So we were discussing on the possibility and to see how we'll go with this draft. So, thank you.
Okay, thanks. Other working group drafts not in the agenda are the OTN ones. Maybe Matt.
Matt Hartley. Yeah, so these drafts there was some discussion of them in Honolulu. We have, based on the comments we got then from mostly from Lou and Adrian, we have made some changes to the drafts so that the IANA types are correct. There was some talk of extending the sub-registry draft to do a similar job on all the IANA registries owned by Ccamp. We haven't done that yet. But what we would like to do, if possible, is to push these drafts through as they're fairly small and clean and simple. And then, given that there has been a fairly large change in personnel in the group, if we still want to go ahead and do a clean-up on all the registries, we could kick off another draft of that. But for now, I think we'd like to. If there's any, I don't think there's any outstanding issues on either draft. If there are, we'd like to have some feedback. If not, we'd like to continue with the process and go through the last call and beyond. Thank you.
Thank you very much. Liaisons and communications. There is a liaison sent to the Q6. It was sent in January on application codes for WSON. It was related to a WSON draft which was in ISG review. We got a reply. From ITU right in these days. There should be no impact on the draft, which is being progressed by the SG. Now, a few words on the routing area reorganization. As all of you probably knows, the routing area has been reorganized with the impact on three different working groups. The TIS working group has been created. They are meeting later this week on Thursday. The TIS will be dealing with the T architectures, generic protocol work for traffic engineering, oversight and coordination of T protocol work. The working groups impacted are Ccamp, MPLS, and PCE. The Ccamp will be in charge of all protocols for non-packet data planes and LMP. The MPLS working group will be in charge of protocol for MPLS TE, including MPLS TP, and all other MPLS work as usual. The PC working group will have to coordinate with TIS on the T architectures which require a PC, which involve the PC. Then there is a lot of work ongoing on Young modeling. Young deliverables will be available almost in every working group. There is, however, a new activity which will start very soon. It's basically the building of a cross-working group design team, which will be in charge to coordinate all the Young modeling work. So, Ccamp impacts, as we said, generic TE work moves to TIS. We will have to cooperate with the TIS very much. What is left in Ccamp? Everything that is non-packet, so FlexiGrid, Ethernet, TDM, OTN, everything that comes to your mind, which is between layer 0 and layer 2. And work on LMP will be progressed as usual. This is just a recap of the drafts that used to belong to the Ccamp and that now have been split between the two working groups. As you see, in Ccamp, we'll be still dealing with the FlexiGrid work, with the WSON, with impairments aware, and so on. Question?
Just one question to the slide before. You mentioned non-packet Ethernet. What exactly does that mean? Just to be precise.
You're right. Non-packet means non-IP, non-MPLS. Non-PSC, right. We have no milestones. Please, Oscar. Mic's down.
Okay, so first of all, I'm going to tell you about the latest update of the FlexiGrid framework. It's been around for almost, I guess, like 3 years. I think it's been around. So I think this is the latest cleanup. Okay, so next slide, please. Okay, so the first thing we did is to do a major editorial review. Lot of thanks to Ramon, who took care of doing the full pass of the document. There they completed all the abbreviations. So now there is a small specific section of the terminology that gets all these abbreviations. Then we added clarified all the ITU terms. So basically, these optical tributary signal and optical tributary signal group and the first 3 frequencies lot, all of them from G870. And also in the document we elaborated this concept of this optical tributary signal. Also we added a new section covering the composite media channels, that is this group of media channels that needs to be treated together as an entity and that should have some specific requirements in terms of routing. Also, we added the section on security considerations of FlexiGrid. Also, we covered the manageability sections, added some missing reference, and then just the editorial issues that update the contributors, the order contributors, the grammar, and the typos. So next slide, please. So I'm going to dedicate a couple of slides in the most important changes of the document. So one of them is this term of the composite media channels. As you know, we have removed the old term of the super channel. Let's say wasn't very welcome by ITU, neither also here in Ccamp. We agreed that that was not the term to use, and we should use a term that is also compliant with ITU. So here the idea is that you are able to construct an end-to-end media channel as a composite of more than one network media channels. Okay, so these composite media channels carry several optical tributary signals, called an optical tributary signal group. So each network media channel carries one optical tributary signal, and the main constraint is that this set of optical tributary signals must go through the same fiber. The question whether they need to be contiguous or not is we leave it open, so it can be or not contiguous. That will be a matter of the technology. And what we don't see so far is a case where you are splitting between several fibers. So the requirement so far is co-routed, so go through the same fiber. And the question of how do we map the signal in this group is out of scope here. As you remember, the scope of the flex grid framework was in managing the spectrum. So here what we basically want is to manage this set of group of network media channels together. Next slide, please. No, the other. I think you passed one. One back. No, next one. The security. Yeah. Okay, so we added a bunch of security considerations. So first, the security considerations of the flex grid system are more or less the same as a fixed grid system. I mean, it doesn't add anything particular to with regard to what's all the security considerations of a normal fixed network. Also, there is nothing specific further from the typical of the GMPLS control plane. So here we added the reference, the RFC 5920, which already covers all the security considerations of a GMPLS control plane. And also we believe that what applies for WSON also would apply to SSON. So that is covered in the RFC 6163, and let's say the possible case of an attack can lead to a bad use of the resources if someone interferes in the advertisement of the available resources. So just to mitigate this, the solution is put these requirements in the routing to use it properly. So next slide, please. So finally, we added the section of the manageability considerations. So first of all, in GMPLS, we already have a good set of tools already available. There are a couple of documents with the MIP modules available, and there is some ongoing work in Yang to cover what is already in these modules, also to cover it in Yang. So we believe that the current mechanisms for fault detection and recovery available in GMPLS will also apply to FlexGrid. Only thing is also, for example, some protocol extensions would need some specific error cases, and which are technology specific in the case for FlexGrid. Also, the same applies to LNP, which applies also to FlexGrid, and here minor extensions would be needed to cover the FlexGrid case. So, next slide, please. So now, after this last review, addressing all the comments in the mail list and do all the Ccamp with ITU, we believe that the document is ready for the last call. There is already an ongoing IPR poll on the list due to the long number of contributors that we know it takes time. So that's all.
As said before, there is an ongoing IPR polling for this draft. Please reply to the IPR polling. Second thing, since both the chair and Oscar are involved in this draft. We will call for the last call, but the consensus will be called by Lou, who accepted, thanks for that, who accepted to be the one calling for the consensus for the draft. If you have comments, please do not wait until the last call. Any time is good for saying anything. Okay, next please.
Thanks, Chairman. This is Hao Mian from Huawei. I will present the following three drafts talking about the FlexiGrid label, RSVP extension, and OSPF extension. So next, please. Yeah, the first draft I'm going to present is flexible grid lambda label draft. In this draft, we define the label format for the flexible grid. And this draft was adopted by the working group in June last year, and it was basically stable since last IETF. And we believe it is ready for the WP last call, and we also suggest we follow the progress of the FlexiGrid framework draft. So last call completed. And so the second draft is about the RSVPT extension. So in this draft, we define signaling protocol extensions and corresponding procedures. And this one is also adopted by the working group in June last year. So in this January, we updated the latest version by adding one more paragraph talking about the compound label, which is newly defined in the label draft. And this will use multiple flexible grid slots. So in the signaling procedure, we also need to support this one. And after this update, there is not much discussion on the mailing list, and we believe most of the issues are addressed and stable. So we also request for the working group's last call and also for follow the progress on the framework draft. Yeah. So the last draft is more complicated, talking about the OSPF extension, and we have some open issue at this moment. So in this draft, we aim on to find the routing protocol extensions and procedures, and we introduce the flexible grid RSC in the ICD. We also include a section talking about how the node can advertise the available frequency spectrum resources. And this one is the progress was same with the other two adopted by the working group in June last year. And there are some open issue after the latest update, basically talking about the per priority minimal and maximal RSP bandwidth advertisement. So we will have some more detail in the next page. And we hope we can have some detailed discussion during this session. And we will update the draft after the discussion according to the results in this working group. And hopefully after we address this issue, the draft will become stable, and we would like to request for the last call before next meeting. So let's see the next page and the detail about the priority RSP bandwidth. So yeah, actually there are two different issues. One is about the minimal, and the other is the maximal priority RSP bandwidth. And it was firstly proposed to align with the requirement in RFC 4202. and to make it consistent with 4203. So let's first review what is going on in these two RFCs. It's that on an interface having standard SDH multiplexing, so RSP at different priority P could reserve any bandwidth allowed by the break of SDH hierarchies, with the leaf and root branch being defined by the minimum RSP bandwidth and the maximum RSP bandwidth at priority P. So after reviewing this draft RFCs carefully, we would like to give the following comments. So firstly, this paragraph is talking about the TDM instead of WDM. So the flexible grade will like to apply mainly on WPM. So this may not be the same case we are talking about. And the second is a little bit misunderstanding in the existing RFCs. It can have two different means. The first one is minimal RSP bandwidth, and max per priority. So that means the per priority issue only applies on the maximal RSP bandwidth. And the second is maybe both of the min and max can have this kind of per priority issue. So the difference between these two understanding is whether we need the per priority minimal RSP bandwidth. So by checking the two RFCs, we would like to prefer the first understanding because the RFC 4203 gives a very detailed extension for OSPF to satisfy the requirement proposed in 4202. And in that RFC, we find the max per priority, and we find the minimal RSP bandwidth is unique. So we do not need to define every priority minimum. So our conclusion is, for this issue, is existing RFCs don't have per priority RSP minimum bandwidth, so we will not have to define it in the flexible grade related draft. But for the priority RSP maximum bandwidth, it may be useful, and we will include this issue in the future version. But there are actually multiple options on implementing this. So the first option is to use the existing field in the ICD, or we can also add the maximal RSP bandwidth field in the available label fields. Use the reserved bits in this figure to specify the priority. Specify the priority information. So basically, we prefer the second option because we think this will make the flexible grade work self-containedly. We can give a clear representation of the per priority issue.
You finally have a question.
Sorry, Lou Berger. Is there any reason that this extension, just this part, for it to be technology specific?
Actually, we are not trying to creating new issues here, and we believe that this is basically on WDM.
Okay, I think there's even option one talks about, were you saying, which existing ISCD, I guess, were you thinking? You're talking about using generic mechanisms to start, and it seems like there's a reasonable discussion there to at least ask people if they think it's useful, because there's no reason why bandwidth has been done in generic ways before. Why do it technology specific here? I don't have a strong opinion, but I think we at least have to ask the question.
Well, the first thing that comes to my mind is, as I said on the list, the first thing that comes to my mind is again the differentiation between bandwidth and portions of spectrum. Spectrum. So, thinking of this, I would tend to say that this is technology specific. But we need to discuss.
Yeah, and that's a valid point, and I think I also said this on the list. We had exactly the same issue with OOO switches, where really we had MEMS, and the MEMS were switching a portion of spectrum that was identified based on the grading, really. And we still, at that time, we said, okay, we're going to use an understanding that we can represent that by bits per second, as encoded in the standard IEEE format. And, you know, we've done mapping tables before. I think you authored that document. Not sure. Ty, you were on it. The G709 piece where we did fixed mappings. So we know how to do it before if we want to do it generic. It's a question of, does it really make sense to do something technology specific when we could do it generic so that we don't have to worry about it the next time?
Okay.
Something to think about.
Rajan here. So to answer, I think, Lou's question, I think there is one more dependent parameter here, right? The maximum bandwidth in bits per second depends on the modulation format also. So I think that was one of the things that we had discussed in the past. So since there are many things that play into the bits per second conversion, so that was one of the reasons why we thought, okay, it's better to have it in the...
Can you speak a bit louder, please?
You're not able to
A
hear?
bit louder.
No. Okay, so can you hear me? I'll repeat. So one of the parameters that impacts max LSP bandwidth conversion to bits per second is the modulation format. I think this was discussed in earlier meetings. So, everybody felt that since there is dependency on other factors, it's probably better to have it in the technology specific part.
Thanks.
I don't know if that's a strong enough argument to move it out, but we could potentially look at using redefining max LSP bandwidth as the number of slots as done here, right? That's another way to look at it.
So I think actually there are two things. The first is that actually all the people think that it is necessary to introduce max LSP bandwidth per priority, right? This I think is very clear. But how to encode it, we don't know. Actually, it's not decided. I think Hao Mian, he copied this format here. You didn't mean that you will use this format to carry the max LSP bandwidth per priority, right?
This is just for reference.
Yeah.
What is included in the existing draft?
Right. Yeah. Okay. Yeah.
Okay, thank you.
I'm Xu Huafu from ZTE. Yes. Yeah. Comparing 01 version with 00 version, there are minor change. The main change is in 00 version, the value of the central frequency granularity is a fixed DLV. In 01 version, the value is an initial times of 6.25 gigahertz. So this is a minus change. Next page, please. Other minor strings include some value example of the central frequency granularity, minimum width and maximum width. And also we added to a section on INA and security consideration. So remain strings are editorial strings. Yes. So we think it might be ready for last call for this draft.
Okay. Well, we could try to see, to poll the interest for this draft. How many of you think that the draft is ready for the last call? No, not so many indeed. And how many think that it is not ready and something is still missing or to be fixed? Okay. Well, at least there's no open issue. Okay, we will take this to the list. Yes, please come to the mic.
I have just concern in the topic treated by the draft that has meaning or not to propose exchange and negotiation about the fact that you have flexible or fixed rate, since I suppose that in the network you don't mix both of them, so you have or one or the other, and you probably configured that before. So there is no meaning to exchange information regarding one of the terms.
So you mean that we can use the menu configuration to do that, and it's very easier than the product stuff, you know. Is that correct?
Yes, but my doubt is if the applicability of this.
Okay, yeah.
One response, you know, in Ccamp, many things can be configured by menu, you know. We also have management system. And also we have Ccamp control plan. So I don't think there's some conflict between menu configuration and LMP, you know, communication.
But maybe it depends. So for example, if the information is dynamic, and then usually we like the control plan staff to do that. Otherwise, if the information is static, usually people prefer to configure that, right?
Okay, but by the way, this is a good discussion. Please keep on the mailing list.
Hello, good afternoon. Giovanni Martinelli presenting an update on the WSON information model with impairment validation. Next, please. So here a quick status. The draft just get some editorial updates. So just a quick recap where we are with this draft. So we received the LS78 from IETF. We integrated those lists of parameters. Then the draft was powered and became working document. And then I guess the next step here would be probably ask feedback on IETF about the full list, since we merge the LS78 parameters with the G680. So that's probably we need some interaction with IETF on this point. And I don't know if you remember, Deborah, we update the draft with some comments on the text, and then I don't know if the only way to go to ITUT is just send a liaison and see what the answer here, or see how we can progress on this. Probably there would be some going to ITUT and back for probably refine the list in a better way as it was done here, but that's the only the only way to go. Okay. So here just a recap about the list. So the G68 is there since a while. The LS78 was the one that the liaison we received. So next one. Next, I should click and okay. Basically the set of parameters avoiding those that are already in the G68 is this one. Okay, so that's it for this. So,
no, if you have something to add, please.
Anything to add?
Okay. Regarding the liaison, I think that's the best way to proceed. I would say that it is a good idea to start drafting a text, sending it to the mailing list so that anyone that wants to review, contribute can do that. And so that we will be able to send it out as soon as possible.
Perfect. Okay, I will do.
Thanks, Giovanni. But you are still here for the next presentation.
So this is the encoding part. So this is still an individual. Next, please. Still an individual draft, and there are some changes that comes from the fact that the WSON document, the general constraint encode document, has a little change in the encoding, and since we reuse exactly the same, we extend the concept of the connectivity matrix. We update in this direction. By the way, just a reminder here, we propose the extension of the connectivity matrix using a new connectivity type number. Next, please. Then this is the change coming from the fact that we integrate the list of parameters coming from the LS78. Here probably is another question to ask to the working group, and I can put in the same text about extending the parameter source or using a new number in the parameter source field. Because this parameter source was defined as 1 by G697. So we are going probably use a new numbers for adding LS78. So next please. Here in this slide I have added some considerations. So either we use a new number as parameter source shows before, or we change a bit the header of this encoding. Probably the first solution is the preferred one, but here again we need to have some feedback from ITUT. Probably another information that I missed to report here is that regarding the G680 Appendix 5, where they list the parameters, G697, there they report parameters for monitoring, and at least when we have the meeting with ITUT in Orlando, Pete Anslow was, at least he agreed that probably we can add other parameters if we need. They are just mentioning that they are not needed for monitoring, but we need for example, for this kind of usage. But that's probably an argument for the liaison as well. Okay, next step here, regarding the working group adoption, that's I leave for the working group of the chair to the side. This draft in particular is tied with the previous one, so the previous one is just an info model. Here is the proposal encoding. And then the next step that authors probably need to move on is on the protocol extension that implements this encoding. The other question again for the working group probably was triggered to my mind from, I remember a mail from Lou a while ago regarding the WSON. I don't know if it's the case to go for an experimental path or not here, but I would leave for maybe future decision. Let's see.
Okay, just trying to answer your first question. The answer is no. It is possible to liaise almost everything, so there is no need to send a liaison related to a working group document. So I would say feel free if you think that it is more convenient to have all the text regarding both drafts into a single liaison. Please go ahead in that way.
That's my feeling.
Okay. Regarding the experimental path, this is I don't know. This is something I didn't think of personally. I would like to pull the working group for this. Is there any opinion? Would you think that if I correctly remember, we had a similar discussion on the WSON drafts. Lou, please correct me if I'm wrong. There was a similar proposal for going for the experimental path on the WSON drafts.
Yeah, it's Lou Berger. That's correct. The thing with experimental is if folks are really unsure if it's the right answer, they're not really going to do ship product based on it.
Mm-hmm.
Or if you have just one vendor who's looking to move forward, experimental is a nice way to go. Unfortunately, experimental doesn't quite mean what it used to. At one time it was, we think this is an interesting way to do it, and we want to document it, and this is a good way for people to go do implementations, and it didn't have a time limit. More recently, the IESG has wanted to put a specific time limit on experimental documents. And so that's pushed people away from using experimental documents. My personal opinion as someone who's never sat in the ISG is I think it's a really bad idea. But we have a new AD, so perhaps she can come back and let us know what she thinks once she's formally on the ISG to see if that position has shifted. So I think it's actually really, really good. I think if we had the WSON documents as experimental, they would have been available much earlier. Now, would that have been a good thing or a bad thing? I don't know.
Okay. Well, we have to wait until the end of the week to have an answer. Okay. Thanks, Giovanni. Okay. Yang modeling presented by Yang.
Yeah, this is Yang data model for WSON. This is first attempt, and we are also aware of other work in parallel. So let's try to give you some snapshot.
Okay. Sorry to interrupt you, but there is a pink note here saying working group chairs. Please inform the speaker to stay within the pink box on the floor. Oh. You are very borderline. Okay, thanks.
Okay. Yeah, I didn't. Amazing. Yeah, next please. This one is basically Yang model for WSON RWA process, which is not impairment aware, nor flex grid. This is just pure the fixed WSUN networks. We have made some progress on the encoding of WSUN specific and generic model. So basically, we try to come up with Yang suggestion as a base model for WSUN technology. Next, please. I think the main scope of this draft, we had like 4 major building blocks: connectivity matrix model, resource pool model, which is basically regeneration or wavelength converter model, and port wavelength restriction and wavelength availability on lanes. So at this particular extension, we focused on the first 2 bullet items to begin with, and we didn't know actually whether we should continue on with this assumption or not because of the fluidity of Yang progress in various working groups, but try to give our first shot. Next, please. Yeah, this is kind of overall WSUN topology module tree structure. To show you some, overall structure, not meant to go detail, but I think you can read the draft for details. Next, please. So I think, the issue is that there are, different WSUN related models are, floating. Particularly a flex grid, we talked to the author of flex grid WSUN Yang model that we need to kind of coordinate each other, and we believe that I think it's a 2 different scope, so we can maybe point to each other and make sure that what are the dependencies. And also there's another draft which is not published under Ccamp, but IETF, which is layer 1 topology model. So there's some dependency possibly. And also Ccamp document, I believe that is the base document we believe that we can augment from. In IETF, that's also IETF, but that gives enough information about namespace and link and node conventions and so on. So we believe that that might be the base model that we should augment from, but also possibly augment from other modules, abstraction topology model, that generic TE working group. I don't know what is the standing of that draft right now, but I believe we need to explore that. And impairment WSUN can be developed later once it becomes stabilized, and maybe to be adopted by Ccamp working group so that we can continue on, whether this is the right direction or not. Okay.
Okay. I've written a question on this paper. I guess Lou is going to ask it. Please.
I defer to the chair.
No. Well, actually, my question is, I think here there is some work that could be considered technology agnostic and some work that could be considered technology specific. For example, the connectivity matrix. Did I guess right?
Let me answer that. Connectivity matrix, here we are concerning about specific technology, specific constraints, which is wavelength level.
Okay.
So whatever connectivity matrix in the upper layer guy is defining, it's not really applicable per se, but we can use the structure, but we have to have that particular technology specific constraints in that way. Although, yeah, it's a generic term, but we are talking about a particular constraint, so not concerned about generic structure itself.
Okay.
That said, I think you're probably right. Lou Berger. What I was going to comment on is actually the description on the first 2 bullets was accurate as of the prior IETF. Since then, there's actually been quite a bit of work done on generic TE models, and that work is going to be presented later this week in TEES. So I think you're right about augmenting other models. I think that's the right way to go. But I think draft clem is now OBE, and it's replaced by other work that's
Okay, yeah.
So it's just sort of point to the other drafts, not the old ones.
What's that called? What is that clem, the draft called now? ODE?
I think it's, I don't remember whose name it is.
Okay.
It's one of those two guys.
Okay.
It's either draft beer or
so I talk to Pavan or Liu?
Stefan.
Okay, okay.
The other thing is I do suspect that there is going to be some pieces that are not in those documents that match some of the generic work that was done as part of WSON and really should belong there. The work that's coming into TEAS, it's still individual. Soon, hopefully, maybe after this meeting, there'll be working group documents, but either way, it's the start of the work. It's not the end of it, so I expect things to be missing. So hearing about that would be really good, and hearing about it from Ccamp would be great.
Yeah, I have one question to you, Lou. When you say, generic model, we have WSON, or generic model. We kind of, I think generic there is basically a label, is generic notation. And the label can be MPLS label, or it can be any type of label. But here we are talking about device model of Yang, that from the WSON device, we need to take those the label, which is wavelengths. So it's very contextual, and we have to be saying that that label is actually wavelengths in this model. When you do information model, we can generalize it, that's true. It can be applicable to other technology, but here we are talking about WSON technology in particular. So we need to take that generic stuff into WSON context and then be able to develop Yang model specific for WSON, because wavelengths is a very specific term, and then we have a lot of, and the name spacing of that, wavelengths is very different than other, conventional, label. So,
Yang is a powerful modeling language, and you can define different ways to represent the same thing. And so there's some choices and trade-offs to be made. And I think that's a good discussion to have with those folks who are actually working on the document. In terms of answering what I think of as more generic, I'm thinking about, like, if you have some switching matrix restrictions. I would think that could be done in a pretty generic way. I don't think that has to be done in a technology-specific way. And I think the document you authored that allows us to do that was a really good step in that direction. I think the same type of thing, I would expect to see that in the Yang models. But I can't tell you if that's the right answer because we haven't done the work yet. So that's part of the discussion.
Yeah, the devil is in the details, so we'll see later.
Igor Bruskin, I'm one of the co-authors of the generic T model. And what I wanted to say is that basically what you describe is T model, right? But it is basically specific to WDM layer. This is exactly what we have in mind by augmenting. So basically, the plan is to augment the model that we are developing, okay, and provide basically WDM layer specific augmentations like link and node attributes. A lot of things are already in this model. For example, you mentioned connectivity metrics, okay, and the very same connectivity metrics that you described, it actually applies, for example, to OTN switches. Okay, so for instance, we have like severely constrained OTN switches where you have to provide connectivity metrics on a link/label level. Okay, that could be also the same thing could be in Ethernet and so forth. So basically, I recommend you to look into this model and to see what is already there. So what we expect to happen is that while you provide an augmentation, it will have to do with, for example, optical impairments and lambda continuity, something like that, wavelength conversion, something like that. Okay, but for example, we do not expect you to work on constraints switching constraints. We do not expect you to do things like SRLGs and stuff like that that are common to all layers as well.
Yeah, I think your generic model has to be really generic and remain as a generic because that's the task I believe. And then we need to see the latest progress in T's working group. Then I'll be able to comment more constructively what you're saying. Okay.
What you're trying to augment, what I was trying to say, that you're trying to augment topologies which are not T topologies, and you are talking about a T topology which is specific to WDM layer.
Yeah, that's why I mentioned about Ccamp draft. Now, whatever you call, it has already basic structure. I think that's the good base that this draft can augment from. And then I need to see, Pavan's and Liu's draft more detail as to what you guys are defining, because I haven't followed your latest draft yet. But we don't want to augment more than necessary components for this because we don't need all those details per se. That's my argument. So, I agree with Lou and you that we will look for possible augmentation as much as we can if it is applicable. But that I need to see more details on that, on other modules.
Regarding that speaking, I think this is a good start, no? And you mentioned the device model. Do you think that will be also define the amplifier models and so on?
Actually, the signal compatibility, the application code, we haven't addressed that, but that's the scope of this. So I think that's probably the next step if a working group endorse this to be as a basis for WSUN stuff. Yes.
Okay. Another point, you mentioned you want to augment many other existing documents. For the interface, I think you should refer the 7223. That is a good starting point to extend for the DWDM interfaces. That's what we would like also to do in our young models.
All right.
Thank you.
So, hi, this is again the LMP draft. I think we ran through that kind of presentation already quite a while. However, in the last meeting in Hawaii, there was a remark that it was not really well understood what exactly is addressed and why. So I added here some, some graphics and some moving parts. To explain a little bit why exactly we're looking into this draft. So if you, what I also want to mention right from the beginning is the non-goal. So specifically to folks which are more handling the hardware, so IQ kind of question 6. LMP sometimes appear to be some kind of dynamic switching protocol for whatever. Which is not the case. So LMP is neither used for signaling or for routing any kind of wavelengths. It's only used to exchange property parameters between two ends of a link, just to make sure that they match. And eventually, if they don't match, you send an alarm. So the motivation problem statement, I mean, you can read probably yourself. It's about how to get access to the optical parameters on one side. And if we talk about optical parameters, we are talking about a G698.2 parameters that have been specified by the ITU. Next one. So again, we're talking about properties, and there's another thing to understand because what means link? And in the case we're covering here, the link is basically east and west of a single reference point. And so ITU introduced two reference points. One is called RS and the other one is SS, which is a sender and a receiver. So if you're referring to the two ends of a link, we are not basically looking at end to end, we are looking at a certain reference point, and there's something east and something west of it. Right? Next one. So now that is the animated part. So it starts here. So what is the motivation? Essentially, when you set up an optical network, there are transponders, there are some optical network elements. So and you need to create it having in mind a certain application. So look at this, and you see that the S, the sender, and the receiver as a reference point, they're basically at the edge of what the transponder delivers or receives, and everything in the middle is called black link. So whatever we have here on the top of our cloud, okay, we know it, but from a black link use case perspective, we can only say, okay, there's some transfer function in the middle between the S and the R reference point, and that's pretty much it. So if we want to create a network or set up a WDM network, the starting point is say, okay, for which class of transponders is it supposed to work? And then based on that class of transponders, you can create your network, and you set it up and measure the parameters for that class of transponder, so such that there is a matching network for that class of transponders. So basically, let's take a 10G network with 50 gigahertz grid according to the application code or ITU with a certain fiber type. So if this is the assumption, you can create such kind of a WDM network in the middle and deploy it right away. Next one. Yeah. Next one. So now, at that point in time, when the network is deployed, there is a reference to the reference point. There is some kind of application code attached because that network has been built, for example, to satisfy a certain application code of the ITU. So for 10G, 50 gigahertz, whatever. So this is what is in the application code, and in a sense, that label, application code, is now attached to this black link setup that is here in the middle. Right. Next one. Okay, now we look at it from another perspective. Say, okay, now that the middle network, the black link, has been set up, how do we deploy transponders? How does it work with the application code? So we start with a factory, so we need to manufacture transponders. Produce the modules again. So
I love animations.
Yeah, sorry. So we had standard application code. So whenever it has been produced, it's produced for a purpose, right? So to satisfy some quality parameters, and some quality parameters are in the application codes. There could be standardized and proprietary application codes depending on the vendor. Next one. Now, then of course, when the module is produced, it gets delivered. Next one. So you plug it into your router. You have all those kind of application codes, all the labels associated with that physical entity. And well, now that the router has it, next one. It's simply connected to the next one, and another one to the optical network, right? So now we see that on the left side there is this black link with all those application codes associated. It could be eventually could be only one, right? If it is made for a single standardized application code. And on the right side we have all those. We have a bunch of application codes that can be satisfied by a certain transponder. To give you a concrete example, a transponder can work on different fiber types, and depending on which fiber type is actually used in the network, you need to use a different application code for that transponder. So now last thing is, so which identifiers will work? Proprietary application identifiers or application codes. So you basically need to figure out, okay, what is the network, for which code has the network been designed, which set of codes is going to be delivered by a certain transponder, and do they match? Is there something in common or not? If there's nothing in common, you better raise an alarm. If there's one application code in common, you know what application code has to be used. So this is not about switching wavelengths. This is not about setting up something. This is basically kind of figuring out what kind of application we're in, so that later on a routing or a signaling can pick the right parameters and ask the right questions. Next one. So has also been discussion about input and output power, whether it's useful or measurable, or whether it should be measured or not. So the purpose of this is basically to see whether the link in between, say, a ROADM and a transponder has some problems. So you can measure both sides and a power value, and just monitoring it. This is not about, again, configuring the wavelengths. This is about supervising power values for the sake of trying to figure out if there's a problem. Some transponder can even adjust power levels to a desired range. Some cannot. So also that is an important information that needs to be changed to say, okay, is a certain transponder type able to adjust to change the power level or not? So the meaning of that power measurement is correlation of power levels across the reference points. And again, there was a lot of discussion whether it's an ITU or not. We are referring here to the Orlando discussion, where the question 6 representative clearly said that wavelengths and power is available to be used in addition to application codes or application identifiers. Next one. So back to the contents of the draft. So it's based on the ITU, what's called Black Link. Also we contain a central frequency. We use the single channel application identifiers. And we add basically the current laser output power, the input power, and have a hook for vendor-specific application codes next to the standard application codes. Next one. So this is how the TLV structure looks like. So again, it's a TLV. So we start with the central frequency, the application, single channel application identifier, which is a number, which is a type. And then there's a list of single channel application identifiers in use, and it could be a list. And on the bottom you see the vendor-specific ones, which contain the OUI, which has been recently introduced in the question 6, to allow also for vendor-specific application codes. Right? Next one. So what has been modified since the last time? We are introducing the vendor-specific application code, and we added also some text to describe the LMP usage, so specifically related to the question about the power measurement and for what is it used. So, next steps, well, whenever there are new parameters coming up from question 6, they're working on 100G, for example, we will add them, keep them aligned, of course. And we also want to add the spectrum parameters MIP whenever it's needed, because I think it's the same kind of use case. And ideally, we would like to go for the working group draft. Questions?
It's Monday. Jet lag.
This is Hamian. I have a question for clarification. For the power monitoring you mentioned in this draft, is it related with the frequency or the port capability for the exchange? Is it related with that, or no matter how much frequency you support, you just use the same mechanism for power monitoring?
It's not related to the wavelengths in a sense. So when we talk about a black link, it's about a single wavelength interface. So in that sense, of course, power monitoring is related to a wavelength because there's only one.
Okay, the reason I raise this point is because you know, in ITU there are different progress for the for example, high frequency part like 40 giga and 100 giga. They have different progress than the lower frequency like 2.5 and 10. But I believe if you using the mechanism of very complicated power monitoring on the lower frequency, it will bring you more cost. So whether it is necessary to make this mandatory is a kind of
yeah. So first of all, it is not mandatory because not every optical equipment can actually monitor the power. So I agree. And if it is monitored, it should of course be compliant to ITU specifications. But this is about a protocol. I mean, we don't really specify how exactly you monitor the power for certain wavelengths. But it also falls in a, let's say, in the same kind of idea to say, let's say, if you have, say, for example, you have a transponder that is able to operate at 100 and 400 gig. Take this example because I know that it's not yet in this application code, but assume it, and you would need to have a different way to monitor your power for 400 and 400 gig. You should know what exactly you need to, how to monitor it on the optical side as well, because you don't know which wavelengths you get, right? So, and that's the thing for the LMP. There's a kind of pre-arrangement to say, okay, look, this is the wavelengths you're supposed to get. We're not telling you that you get it now because it's not switching, right? But this is the parameter set we agree upon, and when then later on signaling kicks in and sets up the wavelengths, you know already, okay, what do you need to monitor?
Yeah.
Right.
Okay, thanks.
Okay. I have a question, or maybe more a comment than a question. When you say that LMP is used for signaling or for routing a label, you mean that when you deal with black links, you're not speaking about routable paths in the sense that they are fixed?
Right. So first of all, a black link is what, you know, the crazy thing with a black link is that it is black as soon as you light it up. Because if you don't light it up, you don't know where the black link parameters are set. So the only way to measure your black link parameter is actually you send the wavelengths, and then you know if it conforms to a certain application code. So it's a little bit like that. So in that sense, yes. So when I'm talking about, let's say, not the signaling, it's also not setting a wavelengths. We're not asking for setting a wavelengths necessarily, but of course, somebody later on sets a wavelengths, and we should inform this somebody that sets the wavelengths about, okay, what are your options? Right. So also, as an example, if you have a stupid WDM error wave guide, there's only one wavelength you can set, all the other wavelengths don't get through. Right? So that would be a kind of information from the optical side towards, let's say, the transmitter. But of course, if you have a colorless, directionless, or even just a piece of fiber, well, just tell it there's a piece of fiber and you can set whatever wavelengths you want. So, again, LMP does not select the wavelengths. It just exchanges parameters, that's it.
Okay, thank you.
Okay, I have one comment for clarification. Could you go back to page 6? Page 6. Yeah. So here in this
wait a second.
Okay, so in this example, you mean that, for example, one end can support identifier A, and another end can support, for example, ABC, and then you are going to introduce LMP to extend this kind of capability, right?
Exactly. So let's say the left side supports, say, a fiber type A.
Yeah.
The right side can support fiber type A, B, and C.
Yeah.
So,
I got it. So in this case, it only matters two ends, right, in the whole network?
Yes.
And so usually when the operator put the equipment together, they actually know this kind of capability. So I think maybe in this case, the operator can just click one button to configure that, to enable A in the end and disable BC stuff.
Look,
so I can just follow the Sergio's opinion made on flash grid, LMP stuff, right? So I think I also have this kind of doubts on this job.
Well, look at it from, I mean, for example, if you take your mobile device, how often did you configure your MAC address in your life, right? You don't need it because it's automatically detected. So as soon as you go somewhere, it just works. And that's the same here. So of course, whatever it can detect, you can also configure.
Yeah.
There's no question about it. And we also have a lot of drafts in SNMP and Young model actually configure that things. So this is not either or. It's an additional option that can be used by with LMP. So I agree with you. It's just an additional option.
Okay, thank you.
Okay, so Gerd introduced the topic very well, I think, and I have to go on with the SNMP map. So this is not the horizontal interface, it's the vertical interface towards the management system. And yeah, the current version of the draft is now number 11. So that means during submission on number 10, we lost some valuable input, and therefore we had to resubmit the document to get all the lost information, all the comments from the Honolulu meeting into the document. So now we are on version 11. Okay, next page. As Gerd mentioned, the horizontal interface and the exchange of the parameters between the DWDM nodes and the interface. So we propose here an interface towards the management system, especially for interfaces specified by ITUT G698.2. And we added in this version further capabilities and proprietary application code or an additional application identifier to support application codes not specified in G698.2. The goal is at the end to have a common way of manage and operate such kind of colored interfaces, and yeah, that's the important issue. Next slide. So additional to all the other things, we introduced this vendor-specific application identifier. All the other points Gerd mentioned, the frequency, that nothing changed there. The power values are still in there. And next page. We added this vendor-specific type using organizationally unique identifier here. It's a 6-bit octet, and to allow us to identify the vendor. Next page. Yes, we have a new co-author on the document. It's Microsoft. We added all the comments from Honolulu, from the last IETF, and added some text to describe the usage of the application code and this special application identifier. I think that's it. Next point. Yeah. Authors think the draft is ready for working group adoption. Thank you. questions.
A quick one. Reading the minutes of the last meeting, if I correctly remember, there was the proposal to take the power out, so to make the draft more, let me say, straightforward. I see the power is still there.
Yeah.
Is there any particular reason not for taking it away, or are you planning to put it into the vendor-specific requirements or whatever?
No. So initially, when we started with this MIP document, there was a special use case for DT that we say where different departments had different responsibilities for the network provisioning. So to give the optical guys the opportunity to configure the optical interface in an easy way, it was more workaround. We decided to allow to set the power here. So now we have Yang, that's config, and we have and we do not really have the necessity to do this via SNMP. So therefore, for Deutsche Telekom, it's okay to remove to set the power. To get the information is necessary, but it's not really necessary for DT. In that case, to set the power via SNMP, when you can do this later on in Yang or via the CLI.
Okay, thank you.
So if you need, then we can remove the setting the power, but it's an option.
Animations? No.
No animation. I think Gert and Rudiger gave a very good explanation on why we need the application code and vendor-specific application code, frequency, and power. So here we just change the way we manage and we share this information, and we have the same goal and the same motivation. There is only one difference here, because we talk about models, young models, and the difference is that while in the SNMP and in the LMP draft, the power is just an information that an element manager or an SDN controller can acquire from the network. In this case, the power is a parameter that the SNMP, the SDN controller can set to the optical interface. Well, what is the contents is pretty clear. We added the vendor-specific application code. We changed, actually was already present in the previous version, but here we changed the format of the vendor-specific application code following the G874 amendment. Next, please. So the G874 just states that there is one parameter that identifies the application code as standard or proprietary, and in case of proprietary application code, the first 6 octets will be the OUE, as Gert just mentioned. Next step, we need again to keep the young models sanitized. because this is quite an important issue that any young draft has. Based on some statistics we did, we have around here 120 draft, and only around 10 can pass the sanitization process. So here is a big goal we have to keep. And then keep in mind that as soon as IQT defines new parameters or changes the parameters, this document will reflect them. So we continue to look at the 698.2 evolution, and not only 698.2. And of course, whenever the flex spectrum will define also the interface model, so the DWDM or the wireless switching interface model, okay, of course, we'll continue to work on this, even if there is already a draft available, not presented in this section, that should be taken care in account. And then finally, if probably it's too early for this one to promote a working group document because the young models are ramping up now, but what is not mentioned for the two previous drafts, that could be valid. Thanks.
Okay.
Xian from Huawei. I have two questions. First one is for the last three drafts, all the three drafts is actually dealing with almost the same amount of information. What is the relationship between the three drafts? Are they competing, how to say, complementary, or they are competing with each other? Like for me, for the MIP and the young, it seems to be competing with each other at least.
Yes, you are right. The SNMP MIB and the young draft, if you want, can compete to each other. It's just a matter of time, but probably whenever the young models will be fully available and also implemented, the SNMP could be, let me say, frozen, not deprecated. And also the technology is going to young models. No? So the young models also give you the benefits to not only get the information from the network, but also provision the network. This is a big plus compared to the SNMP that is quite weak in this sense.
Okay, actually my second question is related to the configuration. If I understand correctly, the application code supported by interface, it should be get from the management system. You should not to set to the interface, right?
Correct.
Because it's a physical constraint.
Correct.
So I don't get
it. In this case, the configuration parameter that you can do are the frequency and the power. Not the application code. The application code is always get from the network.
But when I read the young tree, it's actually read and write for the application code. As for the power, if I understand correctly, application code including the support of a range of the power. So
yes.
if you allow the ability to set the power, it actually might potentially change application code interface support.
Actually, the power should be in some way. In the application code, you have the minimum and maximum transmit power and minimum and maximum receive power.
Yeah.
These are parameters that are proper of the interface you are managing. So these are written on the stone and are based on the hardware.
Yeah.
Other parameter is the current input power and current output power that are used to detect or manage the right working of the interface. And the third parameter that maybe is not added here but should be added is the configuration of the transmit power.
I don't know whether I get my point through. What I want to say is if
so
you allow...
sorry for interruption. I think time's out. Maybe we can discuss more on the list.
You are between the working group and the cookies and coffee, so I don't think anyone is listening to you anymore. But the discussion was very interesting, and please take it to the list.
In the mailing list or offline. Thanks.
Thanks.
So where's the blue sheets?
Everyone signed the blue sheets? We lost them both?